In example number one, we have a series circuit with a 30-volt voltage source, a 30-volt battery, and three equal resistors, which each have a resistance of 4 ohms. Now, we're not going to quite look at exactly how we figure out the specific amount of current or anything along those lines, but we do want to apply the concepts of series circuits to understand what's going on here. We'd like to find the specific voltage at points A, B, C, and D. So the first thing we need to realize is because this is a series circuit and all the resistors are identical, we have to split the voltage. So the current will be the same everywhere because there's only one pathway, but the voltage will be split because I have to ensure that I can get through all three and get back to the battery with 0 voltage. So knowing that each of those is going to cost me 1/3 of the total voltage, and again, that is because the resistors here are all the same. In situations where they're different, we have to do a little bit more complex mathematics, but I'll show that in a future video. For now, we know that they're all the same because they have the same value. So now we can kind of just use some basic arithmetic and realize that to go from the negative terminal of the battery through point A, I don't need to go through any resistors. So I still have my full voltage. I only spend voltage, or my voltage only drops when I go through a resistor. So the 30 volts is what I have at A because I have yet to pass through any resistors. To get through resistor 1, I'm going to drop by 10 volts. That means once I drop by 10 volts and pass through B, I will have 20 volts, 10 less than I had on the other side of the resistor. The same will apply for resistor 2. I have to drop 10 once again to get through that resistor. So at point C, I will only have 10. And finally, to get through the final resistor, I have to drop 10 yet again. And at point D, I should have 0, which makes sense because I should always have 0 when I get to the other terminal of the battery. And as there are no more resistors to pass through, location D must have 0